Hello. Right, I started a minute early, but I will start by first asking if any of the other people here have any questions on the homework, which I suspect there will be. It's all going to be maths. Um, and then we will do more maths. There's a couple of questions that I've received, which I will do. And if there's any other maths, I think we'll stick to maths for today. Topics that you would like to go over or look at some questions, I will try and go for about an hour-ish today. Tree diagrams, yeah, why not? I'll make something up. 7, 11, 13, Leo 10. Right, I'll start with that, given that we can get out of the way. What have we got? 7, 11, 13. Is questions 10, 15 on a calculator paper? I don't know. Yes, question 10 would be a calculator question. Has to be. 15 would not be a calculator question. Hope that helps. Right, so I'll do these in order. So 7, 11, 13. Let's just have a look at what these are. 7 asks you, it's a little bit unfair, some of these questions, because you didn't, some of these topics didn't necessarily come up in the lesson. It was just, this is quite a mixture of random topics, but, so yeah, some of these are a bit hard. The hard lines, but there is, wait, how many? At least one difficult line question that I will be doing straight after this. Because I've been asked two questions, both were really difficult, but I will be doing those as soon as this is done. My pen's not working. Okay. Right. So we have a question here that says to work out the ratio of px to xq. When you get questions like this, where they ask you for a ratio of two things, basically what they're asking you to do is work out this and work out this. Don't overcomplicate it by thinking, oh, what's this ratio business? It's ultimately just saying work this out, which is here, and work this out, which is here. So we're going to work out those two things. Let's just call this X and call this Y for now, so that I can make it clear. You should recognize that this is a right-angled triangle of which you have two of the sides, and you are asked to work out the third side. There is a equation thingy, a squared equals b squared plus c squared, or something like that, where in a right-angled triangle, the two short sides, in this case X and the 16, both squared and added together, equal the long side squared. Question 9 on the year 9 booklet. Yes, I will do that as well. ASAP. Equals the long side squared, which is 20 squared. So 16 squared is 256. 20 squared is 400. X squared is therefore 400 take away 256, which looks like 144 to me. And the square root of 144 is 12, which means that this side here is 12. We can now move on and try and find this bottom side down here. Oh, God. Let me just have a look at other questions. Yeah, I'm going through some of the 10 booklet now. I'll just see what I've missed in a moment. Then the other right angle triangle, the same thing applies. This side squared plus this side squared equals this side squared. So y squared plus 16 squared equals 34 squared. 16 squared is 256. Wait, we knew that from before. 34 squared is 1156, which means that y squared, if you subtract the 256, is 900, which means that y is the square root of 900, which is 30. Let's see what other questions are going on here. Okay, I'll do both of those, don't worry. Right. And then we haven't quite finished yet. We've done most of the work here. This is px there. That is xq. The question is, what is the ratio px to xq? You have worked out px to be 12 and xq to be 30. They just want your answer in its simplest form. A ratio is just like a fraction. You should be able to find common factors. And the highest common factor here is 6. 6 goes into both 12 and 30. 2 times 6 is 12. 5 times 6 is 30. If in doubt, by the way, when you have a calculator, remember, calculators simplify for you. So if I put 12 over 30 into the calculator, it will simplify it to 2/5, and therefore you can always simplify things. Probability equations, I will try and do one of those. There was one in, I'll go over the one, if I can find it, the one that was on the actual AQA exam paper this year. Right, that was that question. Right, so I will, more. May you, yes, I want to do that. The question that you sent to me, which I believe this one, ready to go. I will be there in just a moment. Bum, bum, bum. Right, question 7, 11. Right, 11. 11, right. Equilateral. What you've got to look out for is these words. There are two things that I always note whenever I read a maths exam question. If the word equilateral is there, which tells me that, of course, all of the sides are the same length, and also, although it's not relevant for this question, that the angles are all 60 degrees. I always identify that. And the other word that I always look out for, because it comes up a lot, is just the word square. When you have a square, they should need to tell you that this side and this side are the same length. So often these things do appear when you do these questions. Right. So the question is the perimeter of the triangle greater than 1 meter? Now you can't answer that question until you have worked out what x is, so that you could then work out what these sides actually are, because the perimeter is all of the sides added together. So what we'll do, because it's an equilateral triangle, I'll put two of the sides, doesn't matter which two, equal to each other. So I'll say that 6x minus 10 must equal 4x plus 5 because it's an equilateral triangle. And I will solve this equation, subtract 4x to get 2x, add the 10 to get 15, divide by 2, and you'll get 7.5 for x's. If x is 7.5, then you can just work out what that side is. 6 times 7.5 minus 10 means that this side is 35 centimeters long, and every side is 35 centimeters long because it's an equilateral triangle. And if every side is 35 centimeters long, the perimeter is 35 plus 35 plus 35, which is 105 centimeters, which is greater than 1 meter, because 1 meter is 100 centimeters. And that's how you do that. What else we got here? 7, 11, 13. Right, question 13. All you need to do in question 13, even though it's phrased weirdly, is, well, actually, it's not, it's phrased very weirdly, is expand the brackets. Okay, so let's expand all of this, right? What we're going to get, 5 times 7x is 35x. 5 times 8 is 40. 3 times 2x is 6x, and 3 times b is 3b. Okay, what we're saying is that this is the same as these three lines here. You may not have come across them much, but it means identical to. These three lines means that what's on the left-hand side is exactly the same as the right-hand side, which is essentially the same as an equal sign, but there are slight differences. So we're saying that this is exactly the same as something x plus 13. Let's add, that doesn't work, does it? 35 plus 6. Oh, no, it's fine. 35 plus 6 is 41. And then we've got 40 plus 3b. Okay, this is the bit where it gets a little bit weird. Um, we're saying that this is exactly the same as something x plus 13. Well, I know what the something x is because surely a is 41 because that has to be the same. There's no other x's anywhere. So what's on the left-hand side is the same as on the right-hand side. And then we've got this bit that's left must be the same as what's left there. So as I said, a is 41. 40 plus 3b, which is what's left at the end of this, must equal 13 because what's on these two things are exactly the same. And so now I can work out what b is. If I subtract the 40, I'll get minus 27. And if I divide by 3, I get minus 9, which means that a is 41 and b is minus 9. All I did there really was expand these brackets out and just look at it to say, well, that and that must be the same, and this must be the same. That is what that was wanting you to do. Where did I get the 40 from? I expanded 5 times 8 to get 40. That's what I did. Um, okay. Sorry, I've started with the year 10 booklet only because he came first. 13, and that was it. And then I don't think you've asked question 10 and 15 because you didn't ask me to, but I'm going to assume not. 4, 5, 8, and 13. So I've done 13. 4. Ugh. Okay. 4, 5, 8, and 13. So do you also have any question on capture, recapture? Yeah, I mean, I'll find them. They'll be on Maths Genie. I'll do one. This is, it's horrible. But yeah, I'll do one of those. I forgot about that topic. Just try to. Right, a bag contains triangles and quadrilaterals in the ratio of the number of sides of each shape. So triangles have 3 sides, quadrilaterals have 4 sides. So we're saying that a bag contains triangles and quadrilaterals in the ratio 3 to 4, which is the ratio of the number of sides of each shape. How can the least number of bags could be is 7? Well, how to answer that? I think you just say that if they're in the ratio 3 to 4, then the number of shapes has to be a multiple of 7. Either there'll be 7, or there'll be 14, or there'll be 21, because these numbers add up to 7. So the smallest multiple of 7 is obviously 7. So that's the smallest amount there could be in the bag. Um, a shape is taken at random and replaced. Another shape is taken from the bag. Work out the probability the two shapes are of the same type. Okay, so let's pretend, because you can do this in probability, that there are exactly this many triangles and this many quadrilaterals, so 3 and 4. Okay, if I am working out the probability that 2 shapes are of the same type, that means I could get 2 triangles or 2 quadrilaterals. Okay, 2 triangles, 2 quadrilaterals. The probability of taking a triangle from this bag is 3/7 because we're saying there's 3 triangles and 7 altogether. Yeah, I'll do question 2, no problem. But then the probability of taking another triangle, because it's replaced, um, means that the probability doesn't change. It's still 3/7 because we put it back in the bag. In harder probability questions, you don't replace it until the probability changes the next time you put your hand in the bag. So it is 3/7 times 3/7, the probability of picking 2 triangles. Or we could have picked a quadrilateral, another quadrilateral. The quadrilateral probability was 4/7 because there were 4 of them out of 7. And because we didn't replace it the second time, it was 4/7 as well. When you have more than one option in probability, in this case, we could get 2 triangles or we could get 2 quadrilaterals to get 2 of the same type, then you add their answers together. So the probability here is 9 out of 49. 3 times 3 is 9, 7 times 7 is 49. Plus 4 times 4 is 16 out of 49. 9 add 16 is 25 out of 49. That would be the probability of 2 shapes of the same type. Right, sorry, I'm just going to keep looking up here. 4, 5, 8, and 13. Yeah, I want to do the A9 booklet in just a moment. Question 2222, somebody asked me to do. Oh, God. Two fair dice are thrown. One dice shows a number greater than three. Okay, well, if there's an ordinary fair dice and it shows a number greater than three, then it can be four, five, or six, right? The other die shows a number less than three, so that's one or two. Put these statements in order starting with the least likely. Both dice show an even number. Um, oh God, how do you do that? I think I'm going to do this. Both dice show an even number. The probability of the first dice showing an even number is 2/3. The probability of the other dice showing an even number is a half. Because we're basically going with these options only now. We've already said that it's one of these options. So out of those options, two out of three of them are even numbers for the first one, and one out of two of them are even numbers for the second one. Times that together, and you get 2/6, which is a third. Both dice show an odd number. Well, an odd number from the first dice is one out of three. And for the second dice, it's one out of two, which is one out of six. And then one die shows an odd number and one die shows an even number. My God. Right. The first one showing an odd number is 1/3, because there's one odd number out of three. And the other one showing an even number is one out of two. Or it could be the other way around. You could have the first dice showing an even number, which would have been two out of three, and the second dice showing an odd number, which is one out of two. That is 1/6 plus 2/6, which is 3/6, which is a half. But let's leave it as sixths, actually. Let's go back to that. So it's 2/6, 1/6, and 3/6. And then you can see which one's the least likely. The least likely is that one, so B. Then 2/6, which is A, and then 3/6, which is C. That has got to be the answer to that. Right, let me see where we are. Partition 2 done. So let me go back to 4, 5, 8, and 13. 5. Ugh, okay. Yeah. This is just randomly thrown in here, but let me just tell you, it's really easy, even if you've never done it before. So if I tell you that this is F, which it is, then 3F just means three times everything there. So that's three times this 4, which is 12, and three times this 5, which is 15. Okay? If I tell you this is G, then 2G is 2 times all of that. So 2 times the 5 is 10, and 2 times the minus 2 is minus 4. That's 3F minus 2G. And then what you do is you just do this. So you go across on the top numbers. 12 take away 10 is 2. And 15 take away -4. Be careful, the two minuses make an add. So 15 add 4 is 19. So that becomes 219. It's a weird little bit of vectors. Technically the easy bit of vectors. Okay, well, I've done number 5. Anyway, that was a different thing, number 5, wasn't it? Right. 8 and 13. Okay. My God, how do you do this? Okay, if I have some money in a bank account and I want to, and it's going to earn 5% compound interest, you would multiply it by 1.05. That increases it by 5% for 1 year. If it's for 3 years, you would do 1.05 to the power 3. So if I put some money in a bank account and it earns 5% interest per year, this is how I would calculate it for 3 years because it's a 3 there. And what we're saying is that there's some money we're going to put in and we want it to be worth at least, so I'm going to put more than, just to do it properly, £9,000 after 3 years. We want it to be worth more than £9,000. And so you just treat this like an equal sign. How would you rearrange this equation? If I'm timesing by something and I want to find out what this is, then I would divide all of this to the other side. So do 9,000 divided by 1.05 to the power 3. Which is £7,774.54. And that's the least amount of money we can invest. Oh, in fact, yeah. That's it. So that's the amount of money we can put in. And then if I just show you, if I've got 7,774 pounds 54, and it increases by 5% for 3 years, it will be worth that much money. 9,000 and a bit, which is precisely what we wanted to do. And then I think 13 is what I recall was the other one. And I did 13 already. Okay, fine. Let me just check if there's anything else on this one before I can move on. 4, 5, 8, and 13. Oh my God. Right. Okay, don't worry. I'll check this. This is all the year 9 one, isn't it? So I think I've done everything that anybody asked me from that one. I can move on to t'other one. This here. These are quite hard, these questions, so don't stress too much. Okay, question 9 on the year 9 book. Let me do that one first. That's the first one on the list. God. Right, what is this? Oh, geez. Okay. Um, this is actually a really good question for anybody else who has got their actual GCSE exams coming up very shortly. Um, two identical quarter circles are cut out from a rectangle as shown. Work out the shaded area. Okay. This distance here must be the radius of that circle. Remember this, if we just look at this shape here, is a quarter of a circle. The full circle is like here, if that makes sense. So from the middle to the edge is the radius of that circle. Um, and the radius of this circle must be, because all of this is 12, and these are, cut out from this rectangle, then this must be 6. Okay, and therefore this must be 6 as well, because 6 and 6. Now, and also, just to be clear, this is also 6 because it's also the radius of the circle. Do you see what I mean? That distance there and this distance must be exactly the same. So the area of this whole rectangle is 12 times 6. It is 72. From which I'm just going to take away the area of these two quarter circles. So the way you work out the area of a full circle is pi times the radius squared. If it's not a full circle, a quarter of a circle, you just do a quarter of that formula. So this area is a quarter times pi times the radius, which we said was 6 squared. And this will be exactly the same. So a quarter times pi times 6 squared is 28.3, let's call it, which means this is also 28.3. The whole shape is 72 area, which means that the shaded bit is just the whole 72 minus the two quarter circle areas, which are both 28.3. So 72 minus 28.3 minus 28.3 gives you the shaded area as being 15.4. That is the shaded area. Again, that's a really hard question, so please don't worry. Right, originally you said 4, 5, 11, and 12. We've cancelled out 5. Year 9, question 2. Don't need 5 anymore. 12, 4, and 1. Okay. Um, oh. 50 people took a test. 12, 4, and 1. Before the test, they predicted whether they would pass or fail. 30 people predicted they would pass. I'm going to put a 30 there because that's the people who predicted they would pass. Now, out of those 50, surely the other 20 therefore predicted they would fail. So these numbers all add up. 26 of the people who predicted they would pass did pass. So of these 30 people, 26 people did pass, which means 4 of them failed. Then it says 37 people passed altogether. The people who passed are in this circle and in this circle. So if that has to add up to 37, we've got 26 of them already. 11 of them must go there to make 37. And then in this final circle, because 20 people predicted that they would fail and 11 of them passed, 9 of them must have failed. So that all these numbers add up. 4. Oh God, it looks exactly the same. No, it's very similar, but it's not. 50 people took a test before said 30 people predicted they would pass, which means 20 people predicted they would fail. Is it 36 people did pass? Oh God, now what? Okay. These are the people that passed in those circles, and we know that 36 of them did pass. Of these 36 people, 3 times as many predicted pass as fail. So whatever this number is, let's call it X. This is how you should do this. This 3 times as many predicted they would pass. Sorry. Okay. So these are the ones who predicted they would fail but did pass. 3 times as many did that. Now, these two numbers, this 3x and this x, must be 36. This is how you use algebra to your advantage. 4x is 36, which means x is 9. That means this number here is 9, and this number here is 27. Because that way, 3 times as many predicted that they would pass. And they still add up to 36, these two numbers, because they need to, because 36 people did pass. And now we can fill in the rest of them easily, because 30 people predicted that they would pass. 27 of them did pass, 3 of them failed. 20 people predicted they would fail. 9 of them passed. 11 of them failed. I don't know which bit you want me to zoom in on. Um, that should be fine. Right. 12, 4, and 1. So that was 4. 12 is the last one. And then I think I'm going to move on unless anybody has any last minute requests for my homework. And we'll move on to a couple of the pretty hard maths questions, by the way. But even if you're doing foundation level and you're here, just to be clear, the bits in all of these questions are still relevant. It's just that you don't want to get all of it put together. So this is important to understand. Right, what's happening? A market trader bought 100 loaves at 84p each, 60 packs of muffins. He sold all 100 loaves. Yeah, okay. His target is to make 40% profit altogether. He sells them at a reduced price. Wow, long. Okay. Right. Okay, it's really long, this. But anyway, let's do it. If I bought 100 loaves at 84p each, I mean, it's obviously £84. It cost me £84. Oh, question 11 and 7. Okay, I will get to that after this one. The Can you do some questions from non-calc paper 1 AQA GCSE? Everything I'm doing is that, so I'm not going to do any extra because all of these questions, well, not this one, but a lot of the questions that we have done already would be on a non-calculator paper 1 foundation. And AQA, because a lot of these questions are very much from there. 60 packs of muffins at £1.10 per pack is £66. And then, so that means he spent a total of 84 at 66, £150. Okay. Right. Just to be clear, when we are targeting 40% profit, what that means is that the profit should be 40% of what you spent. Okay. So let's just do that now. 40% of what you spent is £60. So we want to make profit of £60. In order to make profit of £60, we need to sell everything for £210, don't we? Because we spent 150, we need to sell everything for 60 more than that to make £60 profit. So that's what our hope is. Okay, and we have sold 100 loaves for £1.20 each. 100 times £1.20 is obviously £120. But we have sold £120 worth of loaves and 40 of the packs of muffins at £1.60 per pack, which is 64. So far, we have sold everything for 120 plus 64, £184. Okay, so far. But we, as I said, need to sell everything for £210 in order to make a 40% profit on what we spent. So we've still got another 210 minus 184. We've still got another £26 to try and make to hit our target. And we have got 20 packs of muffins left. Um, and we're going to sell them at a reduced price. How much should we sell these for to meet the target? So we need to make £26 and we have got 20 packs of muffins left. So let's divide that 26 by 20. And we just need to sell them for £1.30 per pack, because then we will meet our target. If we sell them for £1.30, we'll make another £26. £26 on top of the 184 that we've already sold everything for makes £210, which is £60 more than what we spent, which is a 40% profit altogether. Right, question 11. First three terms of a sequence when you have an nth term equation. Again, just an answer to the question about a non-calculator. That is very much that. So if I want to work out the first three terms of a sequence, the n in these equations represents the term number. So if when n is 1, that is the first term in the sequence. When n is 2, that's the second term in the sequence. When n is 3, that's the third term in the sequence. So all you have to do is substitute these numbers into where the n is in the equation. When n is 1, you do 6 take away 2 times 1, which is 6 take away 2, which is 4. If n is 2, you would do 6 take away 2 times 2. 6 take away 4 is 2. And then you do 6 take away 2 times 3. 6 take away 6 is 0. And they are your first three terms of the sequence. 720 boys, 700 girls in school. Probability. Okay. Okay. So with this question, the probability that a boy chosen at random out of these 720 boys studies French is 2/3, which must mean that 2/3 of this 720 study French. So if you just times that by 720, you will get 480. So 480 boys study French. The girls, there are 700 girls. 3/5 of them study French. 3/5 of 700 is 420. So 420 girls study French. The number of students who study French is the sum of this, which is 900. That's the answer. Work out the probability that a student chosen at random does not study French. Well, in total, there are, if you add those two things up, 1,420 students in this school. 900 of them study French, which means that the rest of them don't. So if we take off that 900, 520 of them don't study French. Out of everybody in the school is 1420. You don't need to simplify it because it doesn't ask you to. So that'll be that. And that is that. And that's it, isn't it? 10, 7 done. Yeah. Oh, did I not do 11B? Did I do 11B? Did I miss one out? Oh, I did. Right, so back to this. Here is a term-to-term rule for a different sequence. Multiply previous term by 2, then subtract 3. The third term is 31. Work out the first term. So the third term in this sequence is 31. We need to work out the first term in the sequence, so this one here. Right. What we did to get from one term to the next term was multiply by 2, then subtract 3. So what we need to do is go backwards and go backwards here as well. If I subtract 3, the opposite of that is to add 3, and then multiply by 2, divide by 2. So I'm going to add 3 to this number, 34, divide by 2, 17. That must have been the term before. And then the term before that, you do the same thing. So you're doing everything in reverse. It's like an inverse operations thing. So rather than subtract 3, I'm going to add 3, 20. And then rather than times by 2, I'll divide by 2, 10. You're done. First term is 10. And that will be that. Right, okay, I'm going to move on to a couple of questions that were sent to me. Starting with this one. Let me just make sure that the person who sent it is actually here. No, she's not. Anyway, I want to do it. So this is a challenging question on this, and then I will also do capture, recapture, and then the lines comes into the next question in a moment. Right, this is a really difficult question. Okay, so the question asks you to work out the shaded area. We have got a circle and two semicircles inside a square. Remember what I said about squares? Make sure you highlight these things that the sides are the same length. Well, it tells you there, to be fair. But the length of each side of the square is 12. So that's 12, 12. The radius of each semicircle is 3. The radius of this semicircle goes from here to here, which is 3, another 3, another 3, another 3, right? So it's just 3, 3, which is the 12 that we know already. The area of this complete square then is 12 times 12, which is 144, from which, to get the shaded area, I need to take away the other shapes. So the circle and the two semicircles. Now, oh, there was another question. Did somebody ask me another question? No, I think I did that one. Yeah, I did that. Okay. To work out the area of these two semicircles is quite easy because we know their radius. So the radius here is 3. So the area of this shape is, because it's half a circle, a half pi r squared. So pi times 3 squared. And so is this one, a half times pi times 3 squared. Right, they're the same, so we can figure that out later. Right, if I shouldn't really write that there. There's two of them, so I'm going to times that by 2. So that's this bit done. We're going to take that away from 144 later. The hard bit of this question, the really hard bit, is figuring out what the area of this circle is, because in order to work out the area of a circle, we need its radius, and there is no obvious way to find the radius of this shape. Radius being from the middle to the edge or something like that, right? But I'll just tell you how to do it. It's very hard to spot this, but life. If I can remember how to do it myself. Okay, I'm going to draw a line straight down from here to here. Let's do this in green. Then I'm going to draw a line from here to here. Okay. And I'm going to make a right-angled triangle there. Then I know that from here to here is the radius of this semicircle, which we already know is 3. Remember, it's 3 from the middle anywhere around it. So this bit is 3. And then what I'm going to do is I'm going to call this bit R, as in the radius of that circle, because that's what it is, right? From here to here is the radius of that big circle. Then what I'm going to do is use a different color here. This side, I'm also going to algebraically write down what it is. And this is how you do it. If I draw a line all the way from the top straight through that line, then I know it is 12 long because it's the same as this. Okay, so it's 12 all the way down through the middle. This bit here is also R, isn't it? Because it's the radius of that circle. It's the same as this R, essentially, because it's just from the middle to a different edge. And so if I just take this triangle and put it here, because sometimes it's easier to see these things, then this length is 3, because it's that 3 there. This diagonal is this 3 plus this R. And this side, remember, all of this was 12, which means that this bit is 12 minus this R. So that is 12 take away R. And that's what you need to do, because now we have a right angle triangle, and we know what's true about right angle triangles, that this side squared plus this side squared equals this side squared. We are going to be able to find out what R is now. And once I know what the R is, I can just put it into pi r squared, and that will give me the area of that big circle. So that was the challenging part of this question. So let's just do that. So this side, which is 3, plus this side squared equals this side squared. Okay, so that's the two short sides squared equals the long side squared. 3 squared is 9. If you expand this bracket, I'm going to do it quickly, but you should write it out twice if you're not sure. It's 144 minus 24r plus r squared equals, expand the same thing, 9 plus 6r plus r squared. Okay, the r squareds can cancel out, which is nice. 144 plus 9 here is 153. If I add this 24r to this side, I'll get 30r on that side. If I subtract this 9 from 153, I'll get, oh, my head hurts. 153 take away 9 is 144. Okay. And then r is 144 divided by 30, which is 4.8. So I've worked out that the radius of that big circle is 4.8. And finally, I can now work out the area of this by doing pi times 4.8 squared. Let's do that here, which is 72.4. I'll also just work out this bit over here, which is those two semicircles. So that's a half times pi times 3 squared. That's one of the semicircles. Times it by 2 to get the other semicircle, 28.3. Which means that the shaded area is the whole square, which is 144, minus the big circle, which is 72.4, minus the two semicircles, which is 28.3, and we have an answer. 43.3. Should be the answer, if I'm not mistaken. Right, that was it. Simple. Right, next question. C is a circle with a center origin. Now, at GCSE level, you do come across some circles, okay? Those circles will always, on a graph, have a center at the origin, always. Beyond the GCSE, they will move around a bit more. But for now, it will always be at the origin. And when a circle has a center at the origin, its equation looks like this. Okay? Where r is the radius of that circle. So for the distance from here to here, whatever it might be, squared is a number that goes there. So for example, if this radius was 5, then this would be x squared plus y squared equals 25 because you square the radius. Okay? The question wants you to work out the equation of the circle. So that is the equation of the circle. So really the only thing we're missing is this, because the rest of it's just x and y is part of the equation. So we just need to know what that number is, the radius. What are we going to do? It tells you a tangent to this circle. A tangent is a line that just touches the circle on the outside once, passes through the points minus 20, 0. Let's put that over here. And 0, 10. Let's put 0, 10 there. Okay. The tangent goes through those points. If I can draw this properly. Okay, so there's a tangent, sort of. Now, what I can do, and this again takes a lot of thinking, but what I'm now going to do is find the equation of this red line, which is the equation of the tangent. The equation of the tangent is a straight line, so it's going to look like this. I already know its y-intercept is 10, which is nice. I just need to find the gradient. So it goes through 0, 10, and minus 20, 0. When you have 2 points on a line, you can work out the gradient of the line very easily by finding the change in the y-coordinates. 10 to 0 is minus 10. And divide it by the change in the x-coordinates. 0 to minus 20 is minus 20. So minus 10 divided by minus 20 is a half. The equation of this line is y equals a half x, because the gradient is a half. The y-intercept is 10, because that's what is going through the y-axis. So the equation is y equals a half x plus 10 for that red line, which we're nowhere near finished. Then what I'm going to do is remember that when you do these questions, most of the time, this is to do when you see tangents to circles and stuff, you are generally dealing with perpendicular lines because this line from the middle to the edge of the circle where it touches, which is a radius of that circle, meets that circle at 90 degrees from one of the circle theorems. Circle radius meets tangent at 90 degrees. So that red line and that green line are perpendicular to each other, which is great because perpendicular means that the gradient of this line is this flipped over with the sign changed. So not half, but -2. And also, I know it goes through the zero, so the y-intercept actually is just zero. So the equation of the green line is y equals -2x. Now what I'm going to do is I'm going to find the coordinates of this point here, which is where they meet each other. The reason I'm doing this is because once I know what this point is, I can work out the distance from the middle to that point, which is the radius, and that is ultimately what I'm after in this question. So I'm going to now find out where those two lines, the green line and the red line, meet each other using their equations. That is the equation of the red line. That's the equation of the green line. If you ever need to find out where two lines meet each other and they're both y equals, just ignore the y's and put the other bits equal to each other. So -2x equals a half x plus 10. You need to solve this equation. I like to get rid of fractions, so I'm going to times everything by 2. That gives you -4x equals x plus 20. If you add the 4x, you get 5x. If you minus the 20, you get -20 on this side. Divide by 5, and x is -4. I also want to the y coordinate, and just like a simultaneous equation, you can just put that back in to get the y coordinate. -2 times -4 is 8. So the y coordinate is 8. So this coordinate is minus, what did I say it was? 5. 4 -4. This coordinate here is 8. And now all I need to do is find the length of this green line. So from there to there. How do you find the length of a green line? Not of a green line, of a line. You basically create like a right angle triangle out of it. So you kind of go, well, if that's the length of the line I want, and I know that it goes from 0 to -4 here, so it's 4 long there, and it goes up from 0 to 8, so it's 8 there, I've created another right angle triangle, and I can just work out what that length is by doing x squared equals 8 squared plus 4 squared, x squared equals that 64 plus 16, which is 80, which means x, or the radius, is the square root of 80. That is the radius of that circle. And because this formula has the radius squared as part of the answer, this surd squared is just 80. So the final answer to this question is that the equation of the circle is x squared plus y squared equals 80, because you just square that as part of the thing. Just like I showed you when it was 5, we put 25 there. Now it's the square root of 80, so we put 80 over there. And that is that complicated question. Um, right, let me see what other topics. Somebody mentioned capture, recapture, and I think, I mean, so we mentioned a lines topic, which I can't really, I mean, that's it. I mean, that's a hard lines question. Right? That hopefully covers that. Um, Probability equation, I'll do one of, if I can find that one, would be nice. And let me just do capture, recapture. Pointless topic. I shall do it. Um, hmm, okay. I'll do two of these. Carlos wants to find an estimate, as you do, for the number of ants in a colony. So let me just give you a quick background about this topic. The idea is that for some reason, people want to find out the number of um, animals, usually in a large amount of animals. That's usually how it works. Um, Further maths would be worth it to take for GCSE if I'm to do medicine in the future. I'll let me just put you on the spot with that. So the question is, would it be worth doing further maths if you plan to do medicine in the future? Further maths GCSE. Honestly, I don't think it'll make a difference. That's my genuine answer. I don't think it'll make a difference. I think ultimately your grades at A level will, and your overall GCSE grades will dictate whether or not you get into medicine. Whether or not you have done an extra GCSE and further maths, I don't think is necessarily going to make a distinct difference. However, if you plan to do A level maths, then doing the GCSE and further maths will be an advantage for you, at least for the first year of A level. That would be the answer. But I wouldn't do it unless you were planning to do A level maths. I wouldn't do it. So I'd ignore the medicine point. I would just go if you're planning to do it, then I would do that. Is it true that if topics come up on paper one, they won't go on paper two, for example, like vectors? I would say that if topics have come up in paper one, they are less likely to come up in paper two. I wouldn't be as definitive as won't. I would say they are less likely because the reason there are two in your case, but three maths exam papers, is because there's so many maths topics and you can't test them all in a single exam. Therefore, we have more than one maths exam, right? So therefore, logically, you're not going to necessarily repeat loads of topics on the second paper that you've already done in the first paper, because what's the point? So yes, that would be what I would say there. Carlos finds right. So anyway, so going back to this, generally what people want to do is they want to for some reason in a large number of animals, usually they want to find out how many there are, and the way they do it is mental. But this is what they do: they catch a certain number of ants from all of them. Right. In this case, we've caught 60 of them, and they mark those 60 in this case with some way. In this case, with a dye right? Sometimes they'll say they put a marking on them of some sort or a sticker on them or something, I don't know, right? Or they tag them in some way. So they identify, right, here's the 60, we just put something on them so that later we can identify that we caught these 60 before. They then let them all back. And then after a certain amount of time, in this case a week, we catch another 60, right? And we look out of those 60 that we caught, how many of them were marked. So how many of them were the same as the ones we caught previously, as it were. In this case, there were 8. So what we do here is imagine that the total number of ants in this colony is X. Okay. Now, when we caught 60 of them the first time, we marked them. So that means that as a fraction, 60 out of all of the animals, ants in this case, have been tagged, right? So 60 out of however many there are, 10 million, whatever, right? 60 of them have been marked, right? Then later we caught another 60 and 8 of them were marked. So the fraction that has been marked now is 8 out of 60. So out of those 60 that we caught, 8 of them have this tag on. And the assumption is that this fraction will be the same as this fraction, because that's how fractions work, I suppose, right? We're basically assuming that when you caught these 60 and marked them, that fraction that we caught that's marked now will always be the same. So 60 out of however many there are marked, and we'll assume that fraction stays the same. So now we caught 60 and 8 of them were marked. And we basically say, well, those two are equal to each other, because whatever that fraction is will equal the new fraction that we have just caught a week later. And then from here, you work out what x is. So you do 60 times 60, 3,600. X times 8 is 8x, and then just divide by 8. And that means that based on this, there were 450 ants in the colony. Okay, so essentially what that means is that at the beginning, we marked 60 out of 450 of them, right? 60 out of 450, simplified, is 2/15. So 2/15 were marked, and Next time we call 8 out of 60, which also simplifies to 2 out of 15. So the point is, we are assuming that the fraction that we caught the first time or mark it will be the same the second time. I'll just do one more to show you they're all the same. Um, right. Um, this person wants to estimate the number of birds in a sanctuary, catches a sample of 70, and tags each of these birds. So what we have done is, again, if we assume that X is how many birds there are in total, 70 of them have got some sort of tag on them, right? Imagine a little thing around the leg or whatever. Um, 70 of them have been tagged. What question? You can leave whenever you like. I will speak to nobody if I have to. No problem. Um, so 70 out of X is the fraction of tagged birds out of all of these, right? Later, in this case, the next day, we caught 60 more, and out of those 60, 12 of them had the tags that we had put on them earlier. So now the fraction of birds that is tagged is 12 out of 60, right? 12 out of 60 is tagged. And again, we just assume that these two fractions will be the same. And therefore, we just times that way, times that way. 6 times 7 is 42, 4,200. 12 times x is 12. X is 4,200 divided by 12, 350. So we are estimating that there's 350 birds in this thingy. And that is capture, recapture. Right. I will do one probability equation question, and this will be painful for some if you did this exam, because I'll try and find the exact one. Um, sorry, one moment. Um, right, so this was on one of the exams um, just now, AQAs. And I'm just going to do that one. No problem. Um, right. Oh, right. The question is, there are n counters in a box. 6 are black. And then it says 2 are chosen at random. Without replacement. And that means one after another, 2 in total. And then it says the probability that both are black is 1/8. And the question is, find out what n is. Okay, whenever you get these kind of questions, my advice is always write down the colors in the bag. So black, we have got 6. We don't know the other colors, but just put other for now if you like. And always put a total. The total is important because in probability, the denominator is the total. In this case, n is the total. The others, if you needed them, you don't in this question, but if you did, they'd be n minus 6. Because if there's 6 black and 20 in total, there's 14 others, right? In this case, we don't need them because this is a relatively straightforward question. Um, the probability of both being black, okay, both are black. What you have to do is think, well, what's the probability of picking a black the first time? And then what's the probability of picking a black the second time? Well, the first time you pick a black, it is 6 out of however many there are in total. That's the probability, right? That's how you do probability. So the one that you want divided by the total. Okay. Now, the second black, because of the without replacement thing, means that now there is one less black in total because you've taken one out already, and there is one less in total. We call that n minus one because it's just one less than whatever it was. So the second black is 5 out of n minus 1. By the way, for the question somebody asked about tree diagrams, this is more or less, I mean, there's a very complicated example of it, but this is essentially a tree diagram. Um, but but it's not. I know, I appreciate it's not. But it's the same principle. Right. When you want both things to happen in probability, you times their probabilities together. So the first black is 6 out of n, the second black is 5 out of n minus 1. That would be the probability of two blacks, and they have told you that that equals 1/8. So this is how we set up the equation. And now it is a case of solving this equation. When you're multiplying fractions together, you just multiply the tops. 6 times 5 is 30. Multiply the bottoms. N squared minus n is what you'd get when you do n times n minus 1 equals 1 over 8. Then what I would do, a bit like what we did in that capture recapture thing just now, times that by that and times that by that. 8 times 30 is 240. 1 times all of that is n squared minus n. This is a quadratic equation. Get 0 on one side so that you get everything on the left-hand side. You then try to put it into two brackets. It's quite hard, but I'm going to do it quickly. This turns into n minus 16 and n plus 15, because 15 times 16 is 240, which means that your n is either 16 or it is negative 15. It cannot be negative 15 because n is the number of counters. It can't be a negative number, which means n equals 16, and that is the answer. Unfortunately, I cannot do more today on the basis that there are no more questions. For the year 11 students, I haven't necessarily been on every day at 9 p.m., but I will be. Again, I will be tomorrow, and Friday, and every other day, basically. So, but if you do have any other questions, just send them, indirectly. You don't have to do it exactly at 9 p.m. every day. Just send them and we'll figure it out. That's it. I will leave it there. And